For our next fun sheet, it will be about reactants and products and the law of conservation of mass. Standard 9.10 reads, identify the reactants and products of a chemical reaction. 9.11, recognize that in a chemical reaction, the mass of the reactants is equal to the mass of the products. This is known as the law of conservation of mass. So what we need to do, apparently, is make sure that we understand and remember what a chemical reaction actually is. So what is a chemical reaction? We're looking at brand new substances. Okay, that's what we've been talking about with a compound. So we have brand new substances are made with completely different properties. We called this, back when we were talking about physical and chemical changes, this can also be considered a chemical change, thus the word chemical reaction. There are some clues that we talked about when we talked about how can you figure out if a chemical change is actually happening. And we talked about the idea of a gas forming. We were looking at bubbles in different materials actually occurring. When we talk about a solid forming, this was the word precipitate. When precipitates form, typically it happens in a liquid that a solid will form. And it's completely different, often a color change as well, and that's what our next one is. We're looking for color changes, something that is completely different than a color that we started with. It cannot be the same color that we started with. And then the last, I'm going to write this as energy changes. So when we talk about energy changes, we're talking about anything that could be sound or light that was being absorbed or given off, light that was absorbed or given off, like light would be absorbed in photosynthesis, or light being given off in the form of that bright white light, like with that magnesium oxide reaction that I had. And I said, don't look at, and you guys all looked at. Heat could be released, heat could be taken in, so those are the differences between endothermic and exothermic reactions. So what we're going to look at now is how do we write down what actually happens during a chemical change. When we were doing the Elements 4D lab, that's basically what we were doing. If you paid attention, you had an element, then you had a plus sign, then you had another element, an arrow, and then you had the new substance, the compound. We call this a chemical equation. So when we talk about a chemical equation, basically this is going to show what happens during the chemical change or reaction, both of those meaning the exact same thing. So an example of this is down here at the bottom, and we typically call these like a recipe. We can look at that as such. So if we look at the chemical equation that we have below, what we basically have here is a recipe to make water. It's just like in a recipe, you always start with your ingredients, and what you end up with is that new substance, like in this case water, or if we started with eggs and milk and sugar, we could end up with a cake. So we're going to start with the ingredients, and when we talk about a chemical equation, those ingredients are going to be called reactants. Anything on the left-hand side of your arrow are going to be those that react together to make a new substance. So on the left-hand side, we have the ingredients or the reactants. The arrow in the middle, notice it is not an equal sign because these things do not equal the same thing. It makes a completely new substance, as we talked about when we looked at that Elements 4D. The arrow means yields. Okay, it's what it says, what it stands for. We'll talk about that here in just a second. And then anything on the right-hand side are those new substances that you are making. They are called your products. So you always have to start with something before you can ever make it. And thus, we have products. In this case, we just have one. In some cases, we have two or more. It entirely depends on what the chemical equation is. So, looking at the reactants in our chemical equation, we basically have the definition being the substances or the ingredients that you start with. Okay, these are always going to be found on the left-hand side of the arrow. In this case, our two reactants, H2 and O2. So we have hydrogen gas and oxygen gas. Make sure that you write those little numbers as subscripts so they're not as big as the letters that we have just written. That's important. When we talk about the products, okay, those are always going to be found on the right-hand side of our arrow. These are always going to be our new substances, okay, because that's what happens during a chemical reaction or a chemical change. The new substances or those chemicals that are made, in the case that I gave you earlier, it could be a cake, and what we have up here, it is actually water. So what I want you to do right now, I want you to go over to the bottom of the page, in the right hand corner, and I want you to write the formula H2O down in the right hand corner. This is the product. Now, when we talked about the word yields up above, that yields means to produce. Okay, so when farmers talk about how much crops they yielded that particular year, how much corn did they produce? In this case, we're saying that this is going to end up producing a new substance. That's why we don't have an arrow here or an equal sign here, because they don't equal one another. Completely different properties on the left-hand side with hydrogen and oxygen, completely new substance with brand new properties on the right-hand side with water. Okay, we really need to understand the parts to a chemical equation as far as the reactants and the products, but when we look at those numbers, when we look at the element symbols, whether they're by themselves or together, those are really, really important things as well. So we're going to look at just one part of that chemical reaction and chemical equation from the front side of the paper. We're going to look at the chemical formula of H2O. So first and foremost, let's start with the things that we already know. We're going to look at the chemical symbol. So we're going to look at what this chemical symbol represents, and that, of course, is going to be hydrogen. Okay, so each one of the elements are going to represent the symbols, or will represent one of the elements on the periodic table. So we have hydrogen in this chemical formula, and we also have oxygen in this chemical formula. So those are the two types of atoms that make up the compound of water. Then we're going to look at the number that comes out front. Okay, this is the exact same thing that you would call this in math. It is called a coefficient. Spelled the same way and everything. So when we talk about coefficients, it tells you how many of the entire substance that you have. So if you had 2x, you have 2 x's involved. In this case, we don't have an x, we have a water molecule of H2O. So we have 2 molecules of H2O, 2 chemical formulas saying that we would actually be able to write this 2 times. The same way that we could say that we could write X 2 times. Now, the little number down to the bottom right of a letter is called a subscript. And this is what I said we need to make sure that we write very carefully and not the same size of everything else. The subscript in this case, you can actually see it is a 2. And what this does, it tells us how many atoms we have for hydrogen. Okay, it's always found below and to the right. Okay, that's important. It's always found to the bottom right of an element symbol. Notice that there isn't anything here for the oxygen. So what that means, it's understood to be a 1. I want you to write a little number 1 to the bottom right of that oxygen. That's important, okay? It's the same way that if we just have an X in math, we can say and understand that it's to the first power. If we see a number 2 there, then we can say, hey, it's X squared. But when we just see an O, that means we have only 1 oxygen, that there's not 2, there's not 3, there's not 10. So keep that in mind. That's really, really important. So, what does this entire part of the chemical equation tell us? It tells us this. It tells us that there are 2 molecules of water. Okay, and that's what we are looking at as we are talking about what this actually means. So there's 2 atoms of water, H2O. Since that's the case, If you go back and you basically distribute that 2 out amongst your subscripts, we start looking at how many atoms we have of everything. So this gets to the next standard that we're going to be talking about with the law of conservation of mass. The reason that there has to be coefficients at the very front of chemical equations, and remember your coefficients are right here, okay, above or in front of a chemical formula. If you don't see a coefficient, it's an understood one, the same way in math. But the reason there has to be coefficients added to some chemical formulas and some chemical equations is because of this law. The law of conservation of mass. So the law of conservation of mass says, the key word, mass, cannot be created or destroyed. That is what we're going to have to do lots of work with as far as moving forward and being able to figure out what coefficients we have to add. So it's because of this law that what we're getting ready to say has to happen. Therefore, 2 very important statements for chemistry. If we look at the very first statement, it says a chemical equation must be balanced. Balanced has a specific terminology. So the terminology for balance in chemistry means this. When we're talking about the number of atoms in the reactants,
this is a test of the
number of atoms in the reactant. So we have to figure out how many hydrogens and oxygens like we had in that chemical equation for water. But the number of atoms must equal the total number of atoms in the products. So we're going to learn how to count atoms and how to use those little subscripts to tell us how many of each substance we have. That's the first thing it tells us. The next is it's similar. You have the number of atoms you have relates to a certain amount of mass that particular hydrogen gas or oxygen gas would have. So the total mass of the reactants in grams must equal, keyword, the total mass of the products. So what's on the left-hand side of a chemical equation, whether it's an atom or the mass of that substance, has to equal what's on the right-hand side of that chemical equation, whether we're talking about the number of atoms or the number of or the total amount of mass. This is the end to Fun Sheet 910 and 911.